All right, guys, we're going to look at our last factoring lesson here. We're going to find the difference of squares. Now, the key is that difference. So remember that difference means subtraction. So you have to have a subtraction sign for this method to work. And then the last thing is that you just want to you make sure that the squares part talks about perfect squares. So it has to be something times itself, obviously. So those perfect squares like 1, 4, 9, 1, 4, 9, 16, 24, 25, 36, 49, 64, 81, 100. So that's all the way up to 10 squared. So not very many perfect squares technically. So the likelihoods that both of these are going to be perfect squares, not very likely, but let's take a look and see how this works. So the difference of squares basically says that if you have a squared minus b squared, so remember it has to be a minus sign, then to factor it, you would have a plus b times a minus b. Now, what you'll notice is that whenever you were to FOIL that out, that middle term that we normally use, that we call b, that has just x with it, it goes away and makes 0 actually. So that's kind of why these work out that way. And so therefore, if you'll notice that I'm taking the square root of a, the square root of a squared, that gives me a, and the square root of b squared, which gives me b. So this is just a little one right here that you want to remember. So you'll notice I have x squared minus 25. Well, x squared can be written as x times x, so that's a square root. And then 25 can be written as 5 times 5. And so, therefore, I'm going to have the square root of x squared, which is x, plus 5, which is that square root there, and then x minus 5. And that's it. Now, I know that seems, you're like, hey, that's so, like, easy peasy lemon squeezy. And you're like, that's just it. But you're done. It's just the hardest part is being able to identify this, especially when you kind of throw in all of these with factoring together. All right, so if we factor 4x squared minus 49, so the square root of 4x squared is going to be 2x, because that's 2x times 2x. And the square root of 49 is going to be 7 times 7. So here, when I go through, I'm going to have 2x plus 7 and 2x minus 7. And so that, it follows still the same pattern. I'm taking the square root of the first one, the square root of the second one, plus minus, it goes in there. And that, like, really, that is it. Again, just being able to identify, because I would look at that and be like, well, I don't even know that it can be factored. So if you'll notice here, I don't have a perfect square. But remember, way back at the beginning, we can factor out a greatest common factor. So the greatest common factor here is going to be 2. So if I factor out a 2, which means I divide both of them by 2, I would have 25x squared minus 1. Now we have 2 perfect squares. Again, just being able to identify it and using all of my factoring terms kind of sort of together, all those factoring skills, putting those together. So I'm going to then have 2 times, now the square root of 25x squared is going to be 5x times 5x, and then the square root of 1 is 1 times 1, so I'd have 5x plus 1 and 5x minus 1. Again, the order doesn't matter there, but the 2 does matter. You do have to have that 2 out there in front to make sure that you that factors out completely. So it'd be like writing the factors of 30. So we could write those out. But so let's say we have, okay, so 2 times 15. Well, I decided to write 15 as 3 times 5. And then I said, well, the factors of 30 are just 3 times 5. And I forgot that 2 out there. So it's really like 2 times 3 times 5. So you're actually multiplying 3 things together there. So that's why that 2 is still important there, because when I multiply it out, it should give me my original expression there that I'm trying to factor. So here's our normal setup here. So if I have x squared minus y squared, again, it has to be minus. Because if it's not minus, then you're probably going to just look for greatest common factor. because you just have two terms. So you're not even having a trinomial there that you're trying to factor or finding two things that multiply together and add together or subtract together, whatever. So whenever I factor x squared minus y squared, it's just going to be x plus y and x minus y. Remember, you're going to find the square root of your first term and the square root of your second term. So the square root of x squared is x, and the square root of y squared is y. Just kind of sort of keeping that in mind there. So again, this is a pretty short lesson. It's pretty straightforward. Again, the hardest part is just being able to identify it when you just throw all of them in together, like which one am I really trying to do? Remember, if you have three terms, you're looking at a trinomial, which is what we've just been covering, which are going to be like you're finding the factors of that last term or the first time the last term, and they're going to add or subtract to give you that middle term. Or you're looking at greatest common factor, possibly with two terms, or difference of squares. Remember, it must be subtraction. All right, you guys got this. So this is wrapping up all our factoring stuff, and we're going to move on to parabolas in the next unit.